Hello, got my tea. And we are going to do some programming. Okay. Today I thought I might have a go at a program I did in the past, a simpler version of it perhaps, which is a letter drop game. So I got inspired to do this by one of my ex-students who's got a really nice example that I intend to clean up, not clean up because it's very nice the way it is, but to give some attention to and use that one day for this. It's a really sweet animation of some dancing that we can do with processing if we're smart about how we do it, and the student's done a really good job of putting that together. But it was a part of a game where drops would come down and you would be pressing keys to try and match in a kind of rhythm game style. But it reminded me of a game I wrote once for my kids a long time ago when I was trying to teach one of them how to use a keyboard. There's tons of typing tutor applications around, but I mean, I'm a programmer, so I made my own. And I called it the letter drop game because it was just letters dropping from the top of the screen, and you have to try and make them go away before they get to the bottom of the screen. I thought, well, let's do that again this week. A simple one. We're going to start off just with one letter. The ultimate version had many letters dropping, but we'll just start with one. This was just me putting a simple point program up so that I could check that my VS Code setup was working. And there it is, point, good, VS Code's working. Again, we're using VS Code so that anyone can join in with the session if they want. So the link's been shared up on Twitch. That works while the stream is live. It allows you to poke around any of the code in this workspace, which includes the code from last week. But here, let's do letter drop. So like any processing program, we start up with the standards, set up and draw. Okay, nice. If I just want a letter dropping from the top of the screen to the bottom of the screen, that's pretty easy. I'll need to store the letter, and I need to know which letter I'm doing. So I'll need a character to keep track of the letter. I'll also need an integer to keep track of the letter position. I'll use posx and posy. You'll find I have a bad habit of not camel casing things like posx and posy. Well, I don't think it's a bad habit. Why don't we just acknowledge it instead of dancing around it? And in the setup, well, I'm going to randomly choose a letter actually instead of setting one by default, and that's where things can get a little bit fun. But I can certainly set the posx and posy initially, and I want to set the size of the screen too. 600 by 600 is fine for this demo. I'm going to try and keep the coordinates relative so that I can change the size of the screen, experiment with that. Using width and height, good relative values. So I'll start the posx at width divided by 2, which puts it right in the middle of the screen, and the posy at 0, which puts it right at the top. And off I go. So I'm going to pick a character for now. C, remembering that with characters as opposed to strings, we use the single inverted commas, and there can only be one character in there. But now I've got to draw it. So drawing circles is easy enough. Drawing characters is slightly more complicated. We might hit the processing reference to see what it tells us, hey? Ooh, we don't want to see the stream coming at us from OBS. But the processing reference is a nice, useful website. There's no point pretending that I can memorize the processing reference. This is supposed to be me or us showing you how we program. And this is how we program. Look things up online. The challenge when looking things up online, the challenge about being a good programmer is not remembering things so you don't have to look them up online. It's remembering things so when you look them up online, you know whether you're getting the truth or not, because online is full of junk. So the processing reference, which I trust very much, shows me different ways of putting strings on the screen. Now I remember that there's a separate section down the bottom for putting strings on the screen. The text function will just draw some text on the screen for me. That's probably what I want. Now it wants a string here. I think I'm just going to try giving it a character and see what it does. Oh look, there's a version down there that takes a char. Good. There's a text version. This might be a bit too small for you to see on the stream. We can make it bigger. There's a version of the text function that takes a character at an XY position. So that's exactly the one I want, because I'm just putting one character on the screen. Easy. Thought that might be a bit harder. The X and Y position that it's going in are the POSX and POSY that I'm storing. And this should be enough to have a program up and running, although it won't be animated because none of those global variables are changing. I forgot my background, and in fact that character is probably being drawn off the top of the screen here. One thing to keep in mind when you draw something is, where does it anchor? Because the position X and position Y, that's all well and good for a point. Points only exist at one position, but for anything bigger than that, it takes up more than 1 pixel. So just giving it 1 pixel position means what? Does it mean you're talking about where the center of that thing is, where the top of it is, where the bottom of it is? And the language we use for that generally is anchor. So where are these positions being anchored on the ladder? I suspect they're being anchored in the bottom left. And what that means is that if I give a POSY of 0, the character is going to be off the top of the screen where I can't see it. That's my hypothesis. I'll test that out just by bumping up the POSY. I'll also remember to put in my background call. And I think text automatically gets drawn with the fill color, so I think it's going to be drawn white. So we'll make our black background, and I'll just be explicit about the fill. More explicit is always better than less. And good. So I think the experiment has proven the hypothesis. And when I bumped it to 10, you can see the character is now being drawn a little bit further down. But is it bottom left or bottom center? Still don't know. Maybe I can test that as well. I can check the documentation, see what it says. Might not tell me what. There we go. It says float by default the X coordinate of the text. See rect mode for more information. So the rect mode is somehow related. I can give it the width of the text box and the height of the text box, apparently. That's the coordinate of the text, sorry, X, Y, Z. X coordinate text, Y coordinate text. So those ones we're looking at, these string ones, so X, Y, Z. So that's not referenced me towards rect mode, so maybe I can't control that. Well, I'll do an experiment anyway. If the documentation doesn't tell me everything I want to know. My experiment is going to be just to draw a line down the center of the screen to show me exactly where the middle of the screen is. 0 and width divided by 2 height. So that's a vertical line going from the middle of the screen at the top to the middle of the screen at the bottom. And I'm going to have to make sure that stroke is set correctly as well, so that I get a white line, otherwise I won't see it. Restart the task, and there, I can see that line that's showing me the exact center of the screen, and now I can see, yes, definitely it's anchored in the bottom left. And to be 100% sure of that, let's draw a horizontal line that is 10 pixels down. And so it'll go from the left-hand side of the screen 10 pixels down to the right-hand side of the screen 10 pixels down. I'm going to have to find a way to shorten that so I don't have to keep clicking restart. There we go. So the 10 pixel line is definitely in the bottom left of the character. And that's fine for me in this application. I generally like to work with the center of things that I'm drawing, but in this case, it doesn't matter. It's going to work just fine. Let's try and put aside that kind of OCD part of ourselves and just go, it's okay, close enough to the center. But that character is definitely too small. I need to make it bigger. Is there a way to make it bigger? Well, in the See Also section, I'm probably going to find useful things. Oh, look, there's a text mode. Quickly, let's check what that does. Text mode. Oh, shape. It's got something to do with how it's drawn. Model or shape? Probably not what I want to experiment with. We'll look at that another time. Text size looks like it might be more useful. Sets the current font size. Size will be used in all subsequent calls to the text function. There you go. That's what we want. It doesn't tell us what the default is, unfortunately, so we're going to have to guess what a decent size for us is. It's in pixels. That's nice. Doing it in pixels is helpful because everything else we do in processing is in pixels. The reason it might not be in pixels is that fonts and text, there's all kinds of measurements people use for those. Points, ems, these are values that sometimes they're relative values instead of absolute values, and there's reasons for them to exist, and maybe there's reasons to use them sometimes, but when we're doing computer graphics, especially on a fixed size screen like this, it's much easier to use pixels. So that, not very big, it looks like it's about 8 pixels high. It's a lowercase c, so maybe we're looking at like 12 pixels high for the total size that a character might take up. Let's double that, let's go to 24. So text size, just reminding myself of the syntax. The exact name, text size, we'll go with 24. We'll get rid of these lines, we don't need them anymore, because we have answered the question from the experiment. And restart the task. Way, that's good. So that's a better size, but now it's not starting in the right position for me. So maybe I should keep around a this kind of size of the text is going to have to relate to where I start the character, right? Because now that it's 24 big, I've got to start it further up, further down. Sorry. So that's become a number that I'm using twice in the same place to mean the same thing. And anytime you've got something twice in the same in different places to mean the same thing, you've got yourself a magic number. And it's magic because it's magically making things work. And we generally don't like them. We like to pull them out and put them into variables. That's a variable that doesn't change, but still a variable is a good place for it, because we can call it by name then instead of calling it by number, and we can modify it in one place and have that modification appear in many. So I'll call it size because I like short names. And where do I initialize a magic number? So generally we initialize in setup. We declare up here and initialize in setup. But for some reason, something in me feels like initializing magic numbers up here is better. It sets them apart in some way from the other ones. But I can't give a good defense of that preference. Okay, oops, sorry, I'm not even using that magic number yet. So let's put it in there. So the POSY starts at size and text size is size. Now size actually isn't a great name because you can see I'm reusing the name size here. Let's call it text size. And again, my obsession with shortening things mean I have to say txt size instead of putting the one extra character in there, the text. I should be fighting the desire to do that. There we go. Okay, so that was a bit of refactoring, right? Made no changes to the program, but I think made it better. All right, we got a C, but it's not doing anything yet. Let's make it drop. So we just need to animate this guy. Animating requires us to play with the values in the variables, posx and posy. Well, we don't need to touch posx. This guy's going to sit in the middle of the screen the whole time. So I'll put a gap in there because I want to say that this is doing all the setup, this is drawing the text, this is incrementing the animation. I like to have white space between kind of chunks of code, even if I'm not commenting to say what they do. Now we've got an animated C. Might be nice to be able to control the speed of that C, I think, but let's leave it for now. I've also done posy equals posy plus 1 because I was again reminded of the badness of the increment operator. Posy plus plus is the alternate way of saying the same thing, right? And it's an easy way and everyone's used to it, but it caught me in a lecture the other day where posy plus plus didn't do what everyone in the audience expected it to do, because it's an expression that returns a value, whereas posy equals posy plus 1 is a statement. Definitely doesn't return anything. So let's stick with the long one in that case. We'll take an E out of text, but we won't use the increment operator. Nothing if not inconsistent. So now the game is not just to have a drop in character, of course. The game is to then hit the right key and make the character disappear. So processing makes that super easy. One of the things I love about processing is this event model where you just plug into the right function, built-in function, and now you're controlling the event. So the event we're interested in here is the key pressed, which means we plug into the key pressed function. And it's a void function. And this guy fires off every time a key is pressed. Doesn't matter what key, just fires off. In this case, we want to do different things depending on whether the key that got pressed was matching the letter or not. Anytime you want to do different things, you have to have an if-else. So build that little structure there. It's going to be an if-else. So one thing's going to happen when the character does match the letter that's on the screen, and a different thing's going to happen when it doesn't. So what do you reckon I should do if it matches? Well, for the game, I want it to disappear and a new character to appear. And I want that new character to appear up the top again. So the condition to check has the key that's been pressed matching the letter. Well, I know I'm looking for C in this case, but I'm going to use the variable letter in case I ever change that, because obviously I will. I can ask, it's just key, if key. So when I ask for key, I'm going to double check on this in the processing reference, because if I get it wrong, I'll just get strange behavior. So if I control F and key, there's the one I was looking for. I think that key will always be the last pressed key, and there it is. A system variable key always contains the value of the most recent key on the keyboard that was used, either pressed or released. So remember that the key pressed function fires up when the key is pressed. So now that key variable will have the last pressed key, whatever was causing this key press to run. So if that equals letter, and remember we're going to use the double equals, we're in a condition. If that equals letter, then do the thing, make the letter disappear. For now, let's just reset the letter at the top of the screen, because we're not choosing letters yet. So resetting it at the top of the screen means resetting it to POSY. And I don't reset it to 0, do I? I reset it to size, because that's where it started from. So that one line of code is enough to cause it to jump straight up to the top of the screen and give me some of the behavior I want. Now, what should I do if I've hit the wrong key? This is a game, so I should probably demonstrate that I hit the wrong key in some way. I don't know. Shall we, like, make the screen flash a funny color? Yeah, I like that. How do you make the screen flash a funny color? There's a trick, actually. I'm going to try it here. I'm going to see if it works. What I think is that the background call, which we often use at the top of the draw function, is actually drawing a rectangle across the whole screen. So it's like a shortcut for saying draw a rectangle that goes from the top left down to the bottom right, fills the whole screen. So when I write background 0, it's a shorthand for make a black rectangle cover the whole screen. And that means that at the start of the draw function it wipes the screen and makes it black. But it also means if I'm in the middle of something else and I call background, it'll wipe the screen and make it that color. But it'll only do it until the next draw function comes around, because what does the draw function do at the start? It wipes the screen again and makes it black. So what I could do is I say, if you press the wrong key, I'm going to wipe the whole screen and make it red. Let's see if that works. And it should just be a flash on the screen, because then the draw function runs around. So red would be RGB, big R, little g, little b, 255.00. Let's see if that works. Whoops, getting my keyboard shortcuts wrong. So terminal will be reused, something broke. Size cannot be resolved to a variable. Sorry. I changed that variable from size to text size, and it noticed and told me. Yeah, okay, so it's coming down. I press C and it goes back to the top. If I press K, hey, that worked. Nice. That's quite a good effect for you pressed the wrong thing. It doesn't break the program. It's just, well, it breaks my eyes a bit. Okay, so now the C is going back every time I press it. Good. Next step, we don't want to just use C every time. We want a random letter. But how do we get a random letter? So we know how to get a random number, right? Let's check the processing documentation again, and there's a random somewhere. There it is. Random. So random gives me back a floating point number, according to this. And there's reasonable tricks like this one for turning it into an integer. So give me back a number and then I'll turn that into an integer. So random gives me a floating point number, and I can ask for it to come in a range, right? I can say, give me the 0 to the number high, or give it from the low number to the high number. I have some control over it, but it always gives me back a float. It never gives me back a character. So how do I get a character from a float? Well, one thing I know about programming is that characters really are floats. Sorry, integers. Characters really are integers. Back in the olden days, they cheated. They just said, look, everything's an integer. But if you want it to act like an integer, sure, it'll act like an integer. If you want it to act like a character, then we'll make up some way so that the integer gets turned into a character. Let's see if it's got anything here. It doesn't. And the way it does that is with this ASCII table. So the ASCII table tells me, again, this is me searching the internet to remind myself of something, but I've got the background knowledge so that I know what I'm looking at is actually true. I certainly remember that the first ASCII character is null, and then I expect A to start somewhere around 60 something. There it is, 65. But I need the internet to jog my memory. So what this table is telling us, although it's somewhat hard to see here, is that the number 35 is the same as the character hash. And the number 69 is the same as capital E, and the number 107 is the same as lowercase k. So saying if you give me an integer 107 but tell me I want it to act like a character, then I'll turn it into a k for you. So if I get a random number between 97 and 122 and just force it to be a character, should work, right? Should give me one of the lowercase characters. So 97 and 122. Let's do it. Let's make letter not be that anymore. It's going to be random between 97 and 122. But of course, random doesn't include the last, so we've got to up that by 1 to 123. Then we've got to say, no, I didn't want the float you were giving me back. I want that to be an integer, please. And then, I don't actually have to say it, it does it automatically. I jam this into a character variable, and so it says, oh, you mean, you gave me a number, but you really mean character, let's treat it like that. So, let's see if this gives me a character when I run it. Oh, didn't like it. Cannot convert from int to char. So I've tried to jam an integer directly into a character, and it said, no, not going to do it. So instead, I will just force the matter. I'll say, no, definitely put that into a character. Let's try again. And good. Hey, give me a character. And it resets just like before, but it doesn't make up a new one. It just gave me 97. That's suspicious that I got the very first one. So I'm going to keep an eye on that to see if I keep getting A's. But I want now that if I've pressed the right number, the right character, then when I push it back to the top, I also generate a new one. Let's do that here. So I need letter to equal a new random thing. And notice what I just did. I just copied and pasted a bit of code. That again is a sign of something that I've got repetition, 2 different places in my code doing the same thing. Bad idea. I should probably, what we call, refactor that. Now I can't stick this in a variable. I can't put char int random blah in a variable. But what I can do is put it in a function. I can make myself a function that's going to do this job for me. So it's a function that returns back a character. Right? It's building a random character for me. I don't need to tell it anything because it's going to make its own decision about what the random character is. And all it does is exactly that code there and then return it. So return that code. The other advantage here is if I do discover I've got a bug in this, I've got one place that I need to fix it. So I'm going to call that function to get the random character instead of putting that line in directly. And I'm also going to change this line up here to call the function. And that reads better too. In this line of code, letter equals random char, that's quite obvious what it's doing. Whereas down here, char int random 97, 123, not obvious. Especially not if I don't know my ASCII codes. Oh, I got V this time, that's good. Well, now I got, that's an L, E, because I asked for only the lowercase. Oh, look at this. I'm getting all the different ones I want. Good. So there wasn't a bug, it just happened to give me A the first time around. Nice. And on it goes. And I press the wrong one, and I get the red flash. Very cool. So that's my basic letter drop game. Now that's far too easy, right? So how about we speed it up every time we get one right? And we might keep track of the score as well so that we can see how well we go. Alright, if we want to speed up an animation, well, we need to keep track of the speed. At the moment, I'm only keeping track of the positions, so I'm going to call it vel y. I mean, it's velocity in the y direction. I could just call it velocity because I only have one velocity. And I'll start that off at 1 in the setup. So that's replacing the one down here where it tells how fast the y goes up. So by putting it as 1, I'm just giving the exact same program, right? That's a refactor that does nothing. But now that I've put it in a variable, I can control it. What I want to do is that if I've correctly picked a character, we'll speed up, make the game harder, and score a point. So I haven't got a variable to keep my score yet, so let's put that in. The score can start at 0. And now down here, this is my chunk of code that gets run whenever I get the right character. So I will make the velocity faster. Vel y equals vel y plus 1. And I'll make the score go up. You can see why it's tempting to use the plus plus operator, because that's a lot of typing. And this also makes the score go down if I type the wrong thing. Cool. Okay. Running. Whoa, it got faster, that's for sure. Whoa. Okay, I can see a problem here. This is getting fast way too quickly. Alright, I can't keep up anymore. This is the downside of sticking with integers. So as a default, I'll stick with integers in processing because every pixel is an integer. There's no point in increasing the position by a half because there's no such thing as half a pixel. But for something like this velocity that is growing far too fast when I grow it one at a time, I'm going to have to bring in a floating point number to help. Because I want velocity to go up slower. So if I make velocity a floating point number, that allows me to start it off at 1, which is a good starting point. But instead of every time I get the right character, the velocity goes up by 1, why don't I make the velocity go up by 1%? No, 10%. 10%. So to do that, it times by 1.01 or 1.10. So that goes up by 10% now. So that'll go 1, 1.1, 1.22, right? Something like that. My percentages aren't so great. So it'll still increase in speed, but at a slower rate. But that brings in a problem. The problem here is that the pos y is an integer, the pos y is an integer, and the vel y is a float. So when I take an integer and I add it to a float, I get back a float. Yeah? Because let's say this has been increased to 1.1, the position might be at position 10, and I increase it by 1.1, so it goes to 11.1. That's not an integer anymore. How do I put 11.1 into pos y? I can't. I can only then just force it in as an integer, and it'll go in as 11. Right? And then it'll go up to 12.1. That'll get forced to 12. So the float just disappears into nothing. What it means is that to keep track of that extra, we have to put this float is kind of infecting our program. We now have to make pos y a float as well. Sorry, that one can stay in int. Pos y has to become a float so that it can grow in the smaller graduations as well. So now it'll be a float. Now that potentially causes problems here where I draw the text at a floating point position. But processing can deal with that perfectly well. And this is the right place for that to be dealt with because processing will say, look, if you've given me 11.3, I'm just going to put that at pixel 11. And if you've given me 11.9, I'll put that at pixel 12. But in the background, sorry, pause y here. In the background, we're still keeping that 11.3 or 11.9 as a float so that when we times it by 1.1 again, it goes up. And if you look really hard on animations like this, they have a slight amount of jerkiness because it's taking a floating point number that's smoothly going up and turning it into an integer number that's less smoothly going up. But we won't see that when we do the animation. The pixels are too small for us to notice that. But if we hadn't turned pos_y into a float, we would have noticed that there was actually no increase in velocity because we got rid of the floating point too early, took it basically out of our functionality. So we're actually probably not even going to notice the speed up here unless I get quite away. Oh, here we go. Yeah, you can see it speeding up. This is a much better rate. Although again, knowing the maths of this, it's still going to speed up too fast towards the end of the game. I might want to put something more logarithmic in the speed up or something. It's just like old games of Tetris. All of a sudden, you just can't keep up. Whoa, okay. We're not showing the score yet, so I thought it might be fun to show the score. The score is being kept as a number, but when you draw a number on the screen, you're going to have to draw it as a string. That text operation we saw before, text. So it can take a single character, but can also take a string. How do we make one of these strings? Well, I believe there's a way to make a string from a integer, and that processing will do it for us. So if we just chuck an integer into text, let's see what happens if it can convert it into a string for us. Oh, but here we go. There's a string conversion. That's even better. str. You can give it an integer. There's the version. You can give it an integer and it'll turn it into a string for you. Perfect. Let's use str. So now, as well as just putting the letter on the screen, I'm going to put the score on the screen. And the score goes, so it's the string version of score. And the position it's going to go at is the top left. But if I put 0, 0, I know that's going to draw it off the screen, isn't it? So I'll make some smart moves here. Let's use size there. Now we know that the left-hand corner is the anchor. So using a 0 for the X position is actually fine. But I'm going to use a slightly larger number just to bump it off the edge of the screen, give us a small margin. And I think that's all we need. Broke something. Size cannot be resolved to a variable. I did that again. Once these things get in your head, they don't come out. There we go. So there's the score. And as I am very nice, and if I do the wrong one, score goes down. Okay, so a really simple little game. But by this is good enough for a keep a 4-year-old happy, let me tell you. Especially if they've got hold of a computer with a keyboard. Kids love that stuff. Oh. Now, to finish the game, I probably want to make it game over when the character flies off the bottom of the screen. So let's do that. How do we know when a character's gone off the bottom of the screen, and when do we check it? Well, we should be checking it on every single draw call, because that's every chance we have. And we should check it right at the start, before anything at all happens. If the pos_y, which remember represents the bottom of the character, has gone greater than height, then we're off the bottom of the screen. So we should stop the game. We shouldn't do any of the game. So in fact, we need an else here, right? We want to say, look, if the pos_y is greater than, then do something to show the end of the game. Otherwise, do absolutely everything else. All the other game things. I haven't got the keyboard shortcut for indenting blocks in VS Code in my head yet, so you have to excuse me doing this one at a time. So what should I do if I've gotten to the end of the game? Why not just show up a red screen again? Red screen seems to be the universal symbol for you made a mistake. And I don't do anything else, right? I don't draw the character, I don't update the pos_y, it just stays the way it is. Let's see if that works for the end of the game. Okay, let's play the game PSN. I've just realized it might be nice to see my score even when the game is over. So we'll fix that. Now let the game finish. Can't help myself. No. There we go, good. So the game did finish. It would be nice to see my score still being shown. So to do that is I say that at the moment the score bit is only being run when the game is still running. But I want it to run both times. So I could either put it here and put it in here. That's a waste of code, because there's another section of code that always runs, and that's the line down here. So if I take the score out of there, the drawing of the score out of there, and put it down there, then I've got put a red background when you fail, otherwise a black background and all of the game, and then no matter what, please put the text on the screen to show my score. get negative scores. Ah, press the right character. All right. Ticking off the bottom, show me my score. Boom, there we go. Okay, so a really basic little game. Again, I like the fact that you can do quite a bit in not that much code. This is 51 lines of code. This is me writing it as nice as I can, 50 lines of code once I take out that extra line, with all the space that I might need, and fun game. Because of processing, what you can do is take this and turn it into JavaScript. Processing JS, this, as far as I know, will run perfectly well as processing JS, and stick that up on a website, and now you can play this game from any old place you want. That's what I did with the original Letter Drop game. I should resurrect that one, find out where I put it back up, so that we can play the one that it uses arrays and shows many letters at a time. All right, but that's all for now. Thanks for tuning in.